record. Okay, so as I said before, I did want to review that accuracy and precision video, and then I wanted to go over take the quiz and then go over it. So today is our main focus today is about leveling. And the process of leveling is to determine the elevation of points. So you will always know an elevation of a certain point that's referred to as a benchmark. And when you're shooting off that benchmark, you could then determine what the elevation is of other points. So we're going to be looking at some of the packet pages 16 to 20. And remember, the packet is in week 0. And then we're also going to look at some slides. So I'm going to pull up the slides right now. Okay, so what we're looking at here is the first thing is measurements. So we remember the second week of class, I was giving you an introduction to measurements. And there are 5 different types of measurements: horizontal angle, horizontal distance, vertical angle, vertical distance, and then slope distance. And they all have a relationship to each other, whether we're looking at the vertical plane and establishing vertical control, or looking at the horizontal plane and establishing horizontal control. So horizontal distance is what we talked about last week about pacing and taping. And now what we're going to be looking at is vertical distance. Okay, so I'm going to go to the next slide. Take a look at this. So here you're riding on a road. This is called, does anybody remember what this is called when you have soil that's on the side of a road, either going up or going down? An embankment. Embankment. E-M-B-A-N-K-M-E-N-T. Embankment. Okay, so we're looking at point A, and point A, I'm telling you on the left side, has an elevation of 100 feet, and point B has an elevation of 140 feet. So the difference in elevation between these points, which again, they're using delta as the difference, it's 40 feet. So had I known the elevation of point A, let's say point A is a benchmark, and I knew that elevation, I could use something referred to differential leveling to determine what the elevation is at B. And differential leveling is the difference in elevation between the two. Let's look at another example. So here we're looking at a dam, we're looking at a little bridge to the dam, we're looking at 3 different points. Point A is right on where the water surface is. B is a little bit up the embankment where the rocks are. And then C is where the pedestrian is, the pedestrian path. So elevation of A is 550. And the difference in elevation, which somebody would have been able to get from differential leveling, the difference in elevation between A and B is 10. And then also from differential leveling, I was able to get the difference in elevation between B and C. So in this particular case, and let's see where I am, I'm up to Edgar. So Edgar, what would the elevation of B be? If I know the elevation of A and I was able to measure the difference in elevation from A to B and B to C. So what's the elevation of B, Edgar? Okay, maybe not here. Daniel?
Would it be would it be 5 feet, right?
Well, the elevation of A is 550 feet, and the difference between A and B is 10. So what's this elevation?
Oh, it would be 560.
Yeah, you don't have to answer that with a question mark, right? You know it. 550 plus 10 is 560. 560. Okay, and then what about the elevation of C, Daniel?
That would be 8 is 15 feet. Yeah, so that'd be 565.
The elevation of A is 550, but it's the difference.
Oh, I see. It would be 575.
575.
Yeah.
All right. So the whole idea is when you do differential leveling, you know the elevation of a benchmark, and then you're using the differential leveling technique to measure the difference in elevation, and then you're able to calculate what the elevation is. And we're talking about all vertical distances here. So let's take a look at the type of equipment that you're using. You're using a tripod. And a tripod is also, we call it the legs. The legs. So when you're working as a surveyor, you call it the legs. You also have the actual level. This is a level. And there are leveling screws on here to make sure that it is horizontal. So when you work with the legs and then you put the level on top of it and you ensure that the level is indeed measuring something, looking through a horizontal plane. And then you have a field book. And then this is called a rod level. And it has, if you look at the close at the top, there's a bullseye level there. So there's a circle and a bubble going through. And you put this, you see how there's a 90-degree on here? You put this on the rod to make sure that the rod is indeed vertical. And I pulled out the equipment in the classroom so we could look at it. At least those of you who are here can look at it. Okay, let's go to the next. So what is a rod? It's really just a big old ruler, right? A big old ruler. So can you picture setting up this level somewhere and then looking at a place, a point that's below you, and then looking at a point that's above you? So you have this level set up, and the level is only going to look horizontal, right? Actually, if I looked horizontal, right, and I look like everybody sit up straight. I was able to go to Laura, the top of Laura's head, and then I went to the top of, let's say, Connor's head. I would be able to see that there's a difference in elevation between you guys, right? Because I'm keeping this level horizontal. So let's take a look at what it looks like. I mean, go on to the next page. Remember, we have datum points, right? And what is the datum? We are at Beth. What is a datum? What is the datum usually? What? Yeah, average mean sea level, mean sea level. So we know that the elevation of the water at sea level is 0, right? And any point up from the water, and right around here, it's like 230 feet. Any point up from it, we're going to have an elevation, a value above 0. I worked on a project right off the Monterey Fisherman's Wharf. There's a big sports center there. I don't know if you've been there. Excuse me, I kind of talked to you the first day of class about all the projects I worked on, but we were working with elevations of 9. I mean, 9. So it was pretty cool. And so now here is a benchmark. And it's important to remember that a benchmark is a permanent marker, right? And we talked about permanent markers. I'll show you some plans in the future, and you'll see where the permanent benchmarks are in Santa Cruz County. And there's one just that side of the college and one just this side of the college. And I remember 2 weeks ago, I told you, where is North? North is up the hill to the left a little bit. Okay. So there's one, if that's north, south, the bay is south, east. So there's a benchmark, a permanent marker with an elevation east of the college and then west of the college as well. And this is typically what they look like. And actually, I have one. Hang on. Okay, so if we zoomed in, we'd be able to see what the elevation is. It actually has a year on it. I think it says 1959, and there would be an elevation on it. This particular case, they're showing you, oh, there's an elevation of A, so the benchmark is 100 feet, okay? So a benchmark, whenever you do surveying, you always need to know, you need to be surveying off a point of known elevation. Because otherwise you just get the difference in elevation of 2 different points. And you don't even, if you don't know what one of the values are, what the elevation is of one, you can't find the elevation of another. And the whole point of differential leveling is to determine the elevation of points. And that means the vertical distances. So in this particular example, our elevation of point A is 100 feet, and we're trying to find out what the elevation of B is. So let's take a look at what the setup would look like. So point A is on the left, point B is on the right. You set up your tripod with the level about equidistant. And that is one way of dissipating any slight error you might have from geodetic surveying. So whenever you set up, you always try to set up in the middle. And it doesn't mean the exact middle. And I'm sorry, those of you who are not going to see me, but I'll tell you what I'm doing. Right now, I am midway between the two doors in the classroom, right? I don't have to be right on line of the two lines. I could go all the way to the back of the classroom as long as I'm about equidistant, right? And those of you who are in the room, does it make sense to be here where I can see both my points really clearly, right? With a short horizontal angle. Where if I go over here and I'm in between, I gotta look there and then I gotta look there. No point. You always find a place midway between the two, but get in a position that you can see all your points. Okay. Another important reason for seeing all the points is you want to make sure that we're not cutting down any trees, right? To do surveying, right? So we want to be in positions where we're not blocked by anything. All right, so let's take a look at this schematic here. Remember, which was the point, Ashton, which is the point I knew the elevation at?
A.
A. So notice I'm putting my rod, which is a big old ruler, on point A, and I set up in between and I take a shot. And the word shot is another slang that you use in surveying. You take a shot, you get a rod reading, and it's called a back sight because you're coming from point A to go to point B. And why would we be coming from point A, Ashton?
Because it's known.
It's the point that I know the elevation of. So I take a back sight reading and I get some rod reading. And then I basically just spin the instrument. I have the level looking at A, and then I spin it to look at B, and I take another rod reading. Before we even move on to the next slide, you can kind of see what's going on. The rod reading at A is a larger value because A is lower. The rod reading at B is smaller because B is higher. And notice when you shoot A, it's called a back sight. And when you shoot B, it's the foresight because that's where you're going to. Okay, so let's go one more slide. Okay, lots of stuff going on. Let's look at A first. So A has an elevation of 100 feet, and I measure it from the ground surface at A down to the datum, right? So the datum is like a horizontal line. Okay, then R, capital RA, is the rod reading at point A, which is really referred to as a back sight, and it's a BS, back sight. Then I turn the level, and now I take a foresight, which they're representing as RB. Notice that RA plus the elevation of A is equal to RB plus the elevation of B. Does everybody see that? Because where I'm sighting, it's horizontal, and the datum is horizontal, right? So the datum is a horizontal line inside, down below the ground, and my line of sight is a horizontal. So that means elevation of A plus the back sight is going to be equal to the elevation of B plus the foresight. And we do it in a two-step process. So we know the elevation of A. We take the rod reading at A, which is a back sight, and we add those two numbers together. When we add those two numbers together, we get what's referred to as an HI, height of instrument. Now, think of that term, height of instrument. Doesn't that really mean the height about the height of the instrument, like the height of me? But what is actually HI in this situation? Amani. Yes, together, but let's talk about it in terms of the instrument itself. Take a look at the picture though. The HI goes all the way down. Normally, from the datum all the way up to the eyepiece. So it's as if it's the elevation of the eyepiece. So we saw the term HI before, height of instrument. And I'll remind you of it. Our first day of class, we looked at trigonometric leveling. And there was something called the height of instrument. And it was indeed the height of the instrument. You know, if I'm 5.5, right? I'm gonna set my instrument eye, up to here, right? I don't want to be squishing down and I don't want to be tiptoeing, right? I want to be right here. And that really is the height of the instrument. The instrument height is from the ground. We measure our height from the ground. But in this particular case in surveying, height of instrument has two definitions. It could be the height, the actual height of the instrument, or it could be the elevation of the eyepiece all the way from the datum. In leveling, the height of instrument is the vertical distance from the eyepiece all the way to the datum. So you have to remember, there are different times you might see a different definition of height of instrument. That's why a schematic or a drawing is so helpful, right? Did I record? Thank God. Okay, so we know the elevation of A. We take a rod reading, the back sight. We add the elevation of A to the back sight to get the height of instrument. And then what's the next thing? We swing the level. We take the foresight. And how are we going to get the elevation of B? Because that's ultimately what I want. What do I do? Alan. So if I have the height of instrument and I just took the rod reading, the foresight, how can I get the elevation of B? Ellen?
Sorry, can you repeat that?
If we know the height of instrument and we just took a foresight, how could I calculate the elevation of B? Hang on, Monty, you want to just do it? You had a short one. Yeah, so it's the height of instrument minus the foresight, and it gives you the elevation of B. So it's a two-step process. Let's just take a look. Here is the calculation. So equation 1 is, you know the elevation of A, you add to it the rod reading at A, the back sight. You add them together and you get the height of instrument. That's the first equation. The second equation is the elevation of B is equal to the height of the instrument minus the foresight. Everybody good? And just look again. Look again at this picture. Here is the elevation of A. Here's the, here's the point of A. Here's the point of B. The change in elevation between the two is what we're actually determining. And what is that? It's really the difference of the two rod readings, right? Okay. And you could have done the math any way you wanted. You could have done it as one equation, but that's not what it's done in surveying. And I'm going to show you how to set up field books for it. They do it in 2 steps. Okay. All right. So now, so let's take a look at, I'm going to have you take a look. I want to do it by hand. So I'm going to stop sharing this for a moment. And I'm going to do it by hand. Let me stop sharing. And good, the presenter looks better this time. Okay, can everybody see my numbers? These are the same numbers in the slideshow, but I think it's easier when actually, let's go through terminology just to make sure. This is part of the packet. Okay, so elevation, it's the vertical distance above a datum. Everybody good? Can I have a thumbs up? Benchmark is a permanent point of known elevation. Thumbs up. A datum, any level surface to which elevations are referenced and mean sea level is usually used. Thumbs up. Mean sea level, average height of the sea surface. Vertical line, it follows the direction of gravity to the center of the earth. That's a little weird, huh? A vertical line. It really is, no matter where we are on the earth, the vertical line really goes to the center of the circle. I mean, center of the earth. So even though it's a vertical line, but remember that we're always looking at plane surveying because we're working with a small area. And then a horizontal line is basically perpendicular to the vertical line. A level surface, curved surface, which has every point perpendicular to the direction of gravity. Yeah, but again, we're talking about such a small area that it's horizontal. A level line is a line on a level surface. And then leveling, process to determine the vertical position of different points below, on, or above the ground, developing, which basically you're developing vertical control. Differential leveling, most commonly used leveling method. And just to let you know, it used to be called spirit leveling, and you might hear an old person talking about it because it was actually alcohol, like drinking alcohol that was inside the bubble for the leveling. So spirits. Okay. Backsight, first of 2 points sighted at a setup. And it's also called a plus sight. Why would you think a backsight's called a plus sight? Where we're going back down to Tarek, we're up to you. Why is a backsight called a plus sight?
Because if you add
Yep,
that rod value to,
yep, we add it. We add it to the elevation that we know. And a foresight is the second of 2 points sighted. And it's a minus sight. And then the equipment that we're using is a level, tripod, rod, and rod level. Could everybody see this paper pretty well, or do I need to zoom in? Is it okay? Okay, so let's take a look at the leveling notes here, and we're gonna look more in detail at it in a little bit. But for now, let's look at what we're doing. BM stands for benchmark. So that means the benchmark, and this is a top view, so it's a plan view. I'm just going to draw a sketch. Here's my benchmark 1. And I'm actually leveling all the way to benchmark 2. So I'm doing some kind of check. And in between, there are 2 points, and these are called turning points. So let's just call it turning point 1 and turning point 2. Now, this distance is really far. My drawing right here is very far. It's not like I could set up at one point and see everything. So this is a point of known elevation. And this one's a point of known elevation too, but I want to check to make sure it's correct. So this one is a known elevation. And they gave it to us. They said the elevation is 107.34 feet. And this one, I want to check the elevation. Maybe there was a little earthquake or something, and I would just want to check it. So, but I can't have one setup that I could see the benchmark 1 and 2. I have to move from one benchmark all the way to the other one. So I'll wait until you're finished drawing this if you want. So these are all the points I'm going to cite. So I know that I first set up a turning point in effort to get to the benchmark. And what I'm going to do is I'm going to have a setup here. And I'm going to call this setup 1. Setup 1. Should I zoom this in maybe? How's that? And at setup 1, I'm going to shoot the benchmark. And I'm going to shoot the turning point. And when I shoot the benchmark, we're going down the line again. Roberto, when I shoot the benchmark, why do I shoot the benchmark first before the turning point 1? Roberto? I can't hear you. Let me see in the chat. Nope, I don't see it. Okay, Reese, why am I shooting the backside first? Okay, and I know the elevation of this point, right? That's my known point of elevation. So here's my back sight. And I'm going to call it setup number 1. So this is my back sight 1. And then the next thing, what would I shoot next? Olivia,
The foresight.
right? And let's call it foresight 1 because it's still from setup 1. Okay. So I know the elevation of the benchmark 1. I know the back sight. So I would actually add these two together to get the height of instrument of where I'm set up. And then I would subtract the foresight. So all this right here, this back sight 1 and foresight 1 is all the first setup. So let's look at some of the math. Let me, okay. So notice I am going to put some lines on how I would do my field book.
Could you zoom out just a tiny bit more?
Yeah, hang on a sec. You notice how I'm skipping a space? Did everybody notice? Okay, what did you say, Daniel? Zoom out a little?
That's perfect. Thank you.
Okay, great. Okay, so let's take a look at this. And actually, I'm going to get highlighters. Hang on. Okay, so setup 1 is here. I put up the equipment and I'm taking the back sight and a foresight. And I knew it's elevation, right? So here is my back sight of 725. And here is my foresight. This right here is my first setup. I think I want to zoom in a little. How's that? Okay. So what do I have to do? I know, look at benchmark 1. The only information I have about benchmark 1 was the given elevation of 107.34. And then I took a back sight. And what did it allow me to calculate? Mackenzie? If I have the elevation of benchmark 1, and I have the back sight to 1, what do I do with these two numbers? Mackenzie's not here. Laura. I add them, right? Because here's my equation down here. It says the height of instrument at that setup is the elevation 107.34 plus this. So what's that? 11459, right? So all this represents setup 1, right? All this was setup 1. And then I took a foresight at turning point 1. And Jose, now that I have the height of instrument and I have the foresight, what do? What can I find? Subtract it. 114.79 minus 107 is 11352. And what does that number end up being? Notice it's written on the same row as turning point 1 because it's the elevation of turning point 1 from setup 1.
Nice.
Does that make sense?
Makes sense.
Okay, so now I knew the elevation of benchmark one. I set up my equipment between, took a back site, took a foresight. Now I know the elevation of TP1, and now I'm gonna do another setup. Set up 2. And Jorge, I'm gonna take a shot on TP1 because I now know its elevation. And what is that shot gonna be called? Joanna?
I'm not sure. I'm still trying to understand it.
Okay, when you go back and you take a shot on something, remember what it's called? It's called a back sight. And it's back sight 2 because it's the second setup. And then I shoot on the second point that I'm going to, and that's not called a back sight. Joanna, what is it called?
The foresight.
That's right, foresight. So now I'm at setup 2 in green. I take a back sight, I take a foresight, right? And now, let's see. Here is the back sight to TP1. And here is the foresight to TP2. So this right here represents my setup 2. And now I know the elevation of TP1, it's 113.52. And what do I do with the 966? Edgar. Is Edgar here? Edgar, yeah.
You would add it.
Yeah, add it. Because now I know the elevation of 113.52. And now I'm going to add to it 966. So what's that? 122. What is it? 122 point. Somebody do the math.
123.18.
123.18. Yeah, great. Thank you. So this is the height of instrument, 123.18. And then, Daniel, now that I have the height of instrument using that equation, and I know what the foresight is, what do I do to these?
Subtract.
That's right. So you get 120.122.70. So this whole thing was a second setup. Okay, so I knew the elevation of benchmark 1. I set up my equipment between benchmark 1 and TP1. I took a back sight, took a foresight, calculated the elevation of TP1. Then I moved my equipment to the second setup. I took a back sight, a foresight, and now I know the elevation of TP2. And now I go to my third setup, setup 3. And Connor, when I take a shot back to TP2, it's called a back sight, and I'll call it 3 because it's for the third setup. And then when I take a shot to the place I'm going to, it is foresight 3. So here it is. Here is the back sight to TP2. See, it's on the row of TP2. This was the foresight to benchmark 2. This right here, this whole diagonal is my setup 3. So what do? I take the 122.70, which was the elevation of the point I was coming from. I add to it 809. So what's that? 130.79. Is that right? And then what do, Connor?
And then you subtract the 40.
Right, so I got 120.09. So I got the height of instrument and I got the 120.09. Okay, questions?
I have a question.
Yeah, Daniel.
Usually when I see surveyors set up, I feel like they usually shoot like a bunch of shots from one location.
Right. Yeah. Okay. So, and that's what you will do in lab 2. But what happened, well, so let's go over this and then let me bring that up. Okay.
Okay.
So in this case, we knew the elevation of benchmark 1. We wanted to find the elevation of some other point, benchmark 2. They were so far apart that we needed to do 3 setups. They were so far apart, maybe there's a lot of tree coverage. We did setup 1, where we took a backside to the benchmark 1, foresight to TP1, moved the equipment to setup 2, did a backside to TP1, a foresight to TP2, and then moved the equipment to setup 3 and did a backside and a foresight. What's really important, I want you to understand the physical thing that's going on, but at the same time, we want to be organized in this. And this is why I have a space, a row in between each line. Let's take a look at benchmark 1. The only thing we knew about benchmark 1 was its elevation, and we shot it with a backside. TP1, we knew we first got a foresight from it, and then we got a backside. So it's a little confusing that they're both on the same line, right? Because the one to the right, the foresight was done first, then the backside. That's why I color coded this. And notice how I put the height of instrument on a line in between these two. Because the height of instrument doesn't have to do with the benchmark 1 and TP1. It has to do with the equipment itself. So watch what I do. Everybody, watch my hand. I'm going to go, I first elevation, backside, add them together, subtract it, get this. Take this, add it to the new setup, get this, subtract this, get the new elevation. Take the 122.70, add it, this, the backside for the third setup, you get this number. Take this number, subtract this, and you get this. There's a lot, you have a lot of homework problems on this, and you want to do all, in fact, I probably should have homework. You know, today's Monday. How do you guys feel about getting the homework done by Friday night? Because that's going to put you way more prepared for Saturday than doing the homework after Saturday. I think it's worth it. You have Tuesday, Wednesday, Thursday, Friday. You have 4 days to get it done. It's going to be a great way to prepare for the lab. We'll talk about it at the end. So everybody understands now why there's a row in between each one. So when you set up your field books, do that too. Daniel, were you going to ask another question? I still didn't answer your first one. I want to make sure that everybody's comfortable with this first.
I think I just figured out the answer to it, but
Okay.
I can ask it anyway.
Yeah, no, I'm going to answer it anyway. Okay, so this is if you're going from one place to another. So what may happen though, is let's say, everybody can see my paper. Let's say the benchmark's here. And you need to establish a topographic map. And you have all these points all over the place. And you need to determine the elevation for all these points. Well, it's not worth it to keep moving the equipment. Because the most time-consuming part of surveying is setting up and leveling your equipment. So it would be best to just set up in one place, shoot a backside of the benchmark, and then shoot a whole bunch of foresights. The only thing is you have to be careful, right? What if you kick the instrument? What if you kick the legs? What if a kid comes by and kicks the legs? You never know. And you don't know if it's moving either, right? You want to check yourself as you go. So what you might do is shoot 5 and then shoot the backside again to make sure that you get the right value. Then shoot another 5 and then shoot the backside and then shoot another 5 and then shoot the benchmark again. But this is not what we're doing now in the semester. We're going to do this as our last lab. where you have the equipment in maybe only one spot. What we're doing now is we want you to move around so that you get comfortable leveling the equipment. So when you work as an engineer, and this happened to me, I worked for Hayward Baker. I took one surveying class and they threw the equipment at me and said, lay out all these points. And I was like, oh my God, you know, I used it once in class, right? So the more practice you get, the better. Okay. And surveying is so much fun because you're outside, you know, it is really great. All right. So in this case, we're going from one place to another. And, you know, I mentioned the first week of school, I believe, that when they're doing construction at Cabrillo's campus, they'll go off one benchmark and they'll set up a temporary benchmark for the whole time that while they're doing the construction, right? So many times you are coming far away from a benchmark and then you set up a temporary one. Okay. And think of this. You're going to be doing a lot of surveying at a job site on Cabrillo's campus. You're going to shoot off the benchmark and you're going to keep doing setup until you get to the point you want to know. How about if you made a mistake somewhere along the line? Oh man. So when you survey, you don't just go from a known elevation to an unknown one and say, oh yeah, it's 100 feet. Yeah, I'm totally confident. You actually do a loop and close it. You start at the benchmark, you put in your 100, you come back and go, good, I'm fine. If you come back and you're off by a certain amount, and we'll talk about error, you got to do it all over again, right? So that's why you have to be really meticulous. Time's money, right? Okay. Other questions so far? I just wanted to show this just as a reminder. We're not doing this. We're not doing trigonometric leveling, but remember, this isn't a level, right? How come this can't be a level? It's not level. Well, level doesn't go like that. It doesn't tip up. This is either a transit, a theodolite, or a total station. It's called trigonometric leveling. And notice what the height of instrument was. It actually was the height of the instrument. But you're going to see height of instruments in this case, and you're going to see height of instruments where they're height of instruments all the way to the datum. Okay. And there was rod readings here and vertical, and we did all this math. It was all geometry, right? All trig rather. I guess geometry too, but trig. But what we're looking at now is we're going back to, let me share the screen. Let me pull it back to the other one's a little less cluttered. But remember, when you're coming from a point, this is not really called a rod read. I mean, it is a rod reading. You are reading the rod, but it's really a back sight. Okay. And then remember also that on this page, you saw the column was back sight, right? The first column was the point you're at, or the point you were shooting, right? Really point sighted. The next column was benchmark plus sight. The next column was height of instrument. Next sight was foresight, and the last one was elevation. Okay. All right. Let's see. I think the next thing is to read. Yeah, and yeah. Okay. Okay. So now I'm going to stop sharing. And I'm going to pin myself again. All right, we're going to think in terms of math right now. You added, all along, you added the back sights. You subtracted the foresights. Add up all the back sights and add up the foresights. You guys get those numbers? What is the difference? What's the difference between the back site and the foresight? Did you get that? 12.75. Where do you think you're gonna see that number 1275? Remember, you added the back sites, you subtracted the foresights. Connor? Yep. The difference between this and this. 120.09 minus 107.34 comes out to be 12.75. Does that make sense to you? If you started with an elevation of 107.34, you added all the back sites, you subtracted all the foresights, shouldn't the last number be the difference between the back sites and the foresights? What is this? This is a math check. Is it a surveying check? No. It is a math check. If these two do not check, it means you screwed up the math somewhere. Does that make sense? You just messed up the math. I haven't done a surveying check yet. Everybody good? Okay. Let's see if I can show you. Okay, let's say you start at benchmark 1 and you shoot all the way to the Cabrillo construction site. And you want to make a temporary benchmark. And we know the elevation here, we know it's like 230. I can't remember what it is, but I'm just going to make up a number. I know the elevation of benchmark 1 is this. And they're far away from each other, right? So what do I need to do? Beth, what do I need to do? I have to have setups. I need a setup here, setup 1. I need another setup 2, maybe a setup 3. And then what are these points going to be called in between these? Do you remember? TP, turning point. Because it's like I'm turning on it, right? I cite this, I turn on that, I move, I turn on it again. Turning point 1, turning point 2. But remember what I said, you know, we get this magic number of like 241.56 and we say, oh, great, good, we're done. Let's build the whole building based on this. No, right? So what do we want to do? We want to survey all the way back to it. So now we have setup 4 and setup 5 and maybe setup 6. Yes, yes. So let's move this up a little. Let's get it focused. Yeah. So we started at benchmark 1. We knew what the elevation was. We want to put a marker, a temporary marker, right near the construction site at Cabrillo. So we do setup 1. We do a turning point, setup 2, turning point, setup 3, and we get an elevation at the construction site of 241.56. Well, we can't stop there. We have to go back. We have to do a loop. We always do loops. They're also called traverses. They're really closed loops. We have to go back. And we have to put another turning point in, 3, and another turning point, 4, right? And then we come back, we get an elevation of 331 point, let's say 4, 5. So do we have a surveying error? We knew that the permanent marker in the ground, the benchmark was 231.46. We do all this surveying to the construction site. We do a loop to go back and we get 231.46. Is there a surveying error?
I'm gonna say no,
Okay, tell me why, Daniel.
because that last one is an estimate.
Oh, good point. Wow. Good answer. Never thought of it that way. There is an error. The error, the surveying error is 0.01 feet. So now let's think about why you said it wasn't. You're right, it is an estimate. But even though that last number is an estimate, it is a value that you calculated. And it's still off by a little bit. Oops. So no, that was a really great thinking. I didn't even think about that. It's always cool, you know, after I've taught a class for so many times that somebody says something different. It's great. A good point, but it's still an error. So let's go back to this. When you sum up the back sites, sum up the foresights, subtract them and check them with this. This is a math check only. It is not a surveying check. Doing the whole loop and coming back, this is a surveying error. So if, this is so important because like a quarter of the class gets this wrong on the first exam all the time. I don't want anybody to get this wrong, okay? When you check the sum of the back site minus the sum of the foresights and you get a number and it doesn't match the difference in elevation, it means you made a mathematical mistake and you have to go back and do all the math again. It says nothing about how good or bad your surveying was. It's only when you do a loop and come back from one point and go back to it where you could actually see the error in surveying. Everybody got that?
What makes this an error is because that benchmark is known, right?
That's right. What makes it an error is we know that the elevation is 231.46. And if I did all the surveying perfectly, I should have gotten 231.46. And I didn't. So there's an error of 0.01, but we'll talk about errors in a little bit. Because you know, you're always allowed a little error, but we have to figure out, well, what's a little error and what's a big error, right? We have to know what.
I'm sorry.
No,
Sorry.
you go.
So we're assuming that the 231.45 reading is with a valid math check. So the math check came out okay. We
Yes,
got
that's
this
right.
number,
Yeah, Tarek,
but
is that you speaking?
Yes, it is.
Okay, yes, so the 231.45, I'm gonna make believe that I did my math check and everything turned out fine. And with all my math okay, I still have a difference, and there is a little bit of a difference. But I need to know what the allowable difference is. Sorry, the allowable error. Right? What is the allowable error? And it depends on what kind of surveying you're doing. And we'll talk about that at the end of class today. Okay, what are some other questions? I'm gonna stop. I'm gonna go back to gallery view so I could see everybody. Okay, questions?
So a
I'm gonna go-
survey error would mean
Say it
a
again?
survey error would mean basically we didn't measure something right? We took a reading wrong?
That's correct. That's correct.
Okay.
So maybe I measured it wrong, or you're gonna watch a video shortly on how to do surveying. And you're gonna see that when you set up your legs, you have to make sure they don't move and you have to get them into the ground. So maybe you didn't put the legs into the ground good enough and they kind of settled a little, or somebody kicked the legs, or you read something wrong. It's all human error. Basically, if you get a surveying error, it's human error. I guess the math check is human error too, but it's a math mistake.
So then you got to go back and find the measurement that you missed.
No, you don't necessarily. If you're within the allowable error, you'll see in your lab, you spread the error out. And then everything's cool.
Oh, interesting. Okay.
As long as you're within the allowable error, you're totally fine. Okay, I need to get another mask because this one's like saturated now. So just give me a moment. Actually, let me have you watch the video. And I know that Kyle is going to have you watch videos using the exact equipment we have, but I want you to watch this video too, so you get to see it twice because you're not here getting to see it in class. And Amani, you could let's shut that fan off. It's a little cold. So hang on a second. Let me go to my screen. Thank you. Oh, noise. Okay, so let's see. We looked at the packet. We looked at the slides. We still have to learn how to read a rod and set up the level. And I'm going to show you some accuracy. Where's the video? Oh, maybe this is it. I did this last week. Yeah, this is it. Okay, so you guys are going to watch a video. You probably should watch. You want to watch it on mine or you want to watch it on yours? What do you want to do? We'll watch it on mine. Okay, so let me open this up. How long is it? 12 minutes. Hey, I'm gonna put it on a little fast forward, okay? Is that all right with you guys? Sometimes I talk too slow.
The automatic level is our most common instrument for measuring elevation differences reliably. First, we have to learn how to set it up and how to operate it properly. I'm Todd Horton for the Illinois Professional Land Surveyors Association. These three instruments function identically. They are all automatic levels. What makes these levels automatic? Well, each one contains a tiny set of mirrors that move automatically in response to Earth gravity, ensuring that the instrument line of sight is always perfectly level. If the instrument settles during use, this automatic compensator adjusts the line of sight simultaneously. Here you can see the top of the mechanism moving as the instrument is tilted. Because they contain compensators, automatic levels give greater precision than older uncompensated instruments can. In this view, you can see that each telescope has a telescope eyepiece and a leveling base. The simplest and most reliable modern instruments use 3 leveling screws. Here you can see the objective lens and the objective focus knob. Each instrument has a circular bubble level. When the telescope is properly leveled, the telescope line of sight is perpendicular to the direction of gravity. Some instruments include a small mirror that enables viewing the bubble level from the end of the instrument, like you see here. This convenient feature speeds up the setup process. Let's demonstrate the instrument setup process for an automatic level. First, with the tripod legs fully extended, mount the instrument on the tripod head. Many tripods use locking clamps to fix the leg lengths. Here's a closer view showing how to attach the instrument to the tripod. The instrument has a coarse internal thread in the center of its base. This matches a loose mounting bolt attached under the tripod head. Thread the bolt into the base, but before tightening it, align the 3 leveling screws with the 3 corners of the triangular tripod head. This will simplify the remainder of the setup. When you extend the tripod legs, adjust them to ensure that you'll stand comfortably with the eyepiece at your standing eye level. You are more likely to misread the level rod when you're bent over like this. Next, move the instrument to a convenient location and spread the tripod legs evenly apart, keeping the tripod head nearly level. When you move the instrument around your project site, carry it in the upright position while still mounted atop the tripod. Spread the tripod feet at least 3 feet apart to make the tripod stable. If they're too close together, the whole thing will be top heavy and unstable. To plant the tripod legs firmly into the ground, apply your full weight to each foot peg. This works on bare earth, grass, concrete, and asphalt surfaces. On concrete surfaces, use grooves, cracks, or holes in the concrete to secure the tripod feet when possible. Even on a sidewalk like this one, your weight will help the pointed tripod tip to settle into the rough surface texture. On asphalt surfaces, you'll see the pointed tips penetrate more on hot days and less on cold days. When you must set the tripod on a hillside, set 2 of the tripod legs on the downhill side of the instrument, as you see here for stability. After planting the tripod feet, you'll be ready for the first of 2 phases of leveling. And that first phase is course leveling. While viewing the bubble level, adjust the leg lengths to move the level bubble partly into the circle. First, watch how a centered bubble moves when the tripod leg length changes. When I shorten the leg under the eyepiece here, you see the bubble move away from that leg. When I extend that same leg, the bubble moves toward that leg. Why is that? Well, the bubble always moves to the highest side of the instrument, like you can see in this side view of the bubble tube. Here's a trick I use to change the leg length. Notice how I grip one of the upper rods of the tripod leg and press my thumb on the lower half of the leg. After releasing the clamp, I can relax my grip to allow the leg to shorten under the instrument's weight. Or I can adjust my grip and push with my thumb to make the leg longer. You'll need to adjust the leg length while watching the bubble to get it partially into the circle. In this scenario, you can see the bubble is off center. Changing the leg length will move the bubble either toward the circle or along the level wall. In this case, it moved along the level wall. Therefore, I'll stop adjusting the leg when the bubble lines up in line with another tripod leg. Then I'll shorten that leg to move the bubble into the circle. One more adjustment with the first leg moves the bubble just a little bit more. Now, this is the end of the coarse leveling phase. Now, to fine level the instrument, that is in the second phase of leveling, center the bubble by adjusting the leveling screws using the left thumb rule. Before I explain the left thumb rule, let's see how we must level the instrument in 2 directions. Using 2 screws simultaneously, you can level the instrument left to right and right to left. Since the knobs in the leveling base are actually turning on screw threads, you're shortening one screw while extending the other. Well, using the 3rd screw alone, you can level the instrument back to front and front to back. So the left thumb rule works this way. With the eyepiece centered between 2 leveling screws, turn those 2 screws at the same speed in opposite directions. The bubble will move in the same direction as your left thumb. Use these 2 screws simultaneously to move the bubble left to right and right to left. Then, to move the bubble forward or back, use the 3rd screw by itself. When the bubble is centered, turn the instrument 90 degrees roughly and ensure that the bubble returns to the circle. If it doesn't, adjust the screws and recheck it. If upon rechecking it, it's still not centered, well, then the instrument may require maintenance. Now, with fine leveling complete, you're ready to aim and measure. This instrument has an aiming sight. Light shining on the front of the aiming sight illuminates a white arrow like this one. When the white arrow roughly aligns with the level rod in the distance, you'll find the rod easily through the telescope. This instrument simply provides a groove along its top side to assist with rough aiming. This one has simple aiming sights like you would find on a rifle. Use your aiming sight along with your slow motion screw to find the rod easily. Each of these three instruments has a slow motion screw. The slow motion screw has a knob on both the left and right sides. Turning either knob will adjust the instrument direction smoothly and slowly and help you refine your aiming. Your first look through the instrument usually gives a blurry view. So adjust the objective focus knob, that is the biggest knob, until you see the rod markings. With your slow motion screw, refine your aim until the crosshair allows a reading. Often the crosshair may not be visible at your first look. The crosshair isn't broken or missing, it's merely out of focus. Rotate the eyepiece until the crosshair comes into its sharpest focus. Now, it's time to test your focusing results for parallax. Parallax exists when the crosshair appears to move up and down as you move your head.
This is really
slightly
important.
Up and down. If you detect parallax, refocus the crosshair to its sharpest and darkest condition, and then adjust the objective focus as needed. A few fine adjustments usually get rid of parallax. The mark you see here above the leveling screw indicates the center of the adjustment range.
If you don't check for parallax, that's another reason that you might have a surveying error.
In the screw. After all measurements are complete, and before removing the instrument from the tripod, return the leveling screws to their centered positions. The next time you remove the instrument from the case, the screws will be centered and ready to use. Following these steps consistently will help you to minimize errors and to work with confidence. I'm Todd Horton for the Illinois Professional Land Surveyors Association.
Okay. Okay. So let me go back to our module. And so we're going to start learning how to read rods. And then I'm going to have you level the levels as well. I'm going to have you screw them. So we're going to pull a bunch out in a little bit. How are we doing on time? We're still good. Okay, so let's take a look at reading rods. And the first one we're going to look at is a sheet that's in the packet. Okay. I'm going to stop sharing. I'm still pinned. So can you see it big? You could see it big, right? Okay. Do you notice the 4 is bigger than the 9, 8, 7, 6, 5? Could you tell that? Right? Okay. And then if I push the paper up, you're going to see, oh yeah, there's the 3, and that 3 is bigger. This is always in red. The 3 is in red and the 4 is in red. And we have, we'll take a little break in a little bit and you'll get to see some of the equipment. So the red numbers, I don't think I could minimize it anymore. I don't think I can. Oh, let's see that. Yeah, and I guess you see both now. So that represents a foot. So the red letters, the red numbers rather, mean it represents the foot. So if you're reading here, anywhere between here and here is 3 feet something. And anything above the 4 would be 4 feet something. Okay. Then the next is the black numbers. And the black numbers represent a decimal foot. Okay. And then above, and I'm going to say just above and below the black bars is, what would you say, not a decimal foot, it would be so this is the tenths place, right? Tenths, you guys? And this would be the hundreds. And then between, no, maybe not between the bars, between, well, I'll show it to you in a little bit. Okay, so I want you to, let's look at the difference between the 3 and the 4. It is kind of confusing. You know, you've never read anything like this before. Notice at the 3, the bar comes out to be a point. Does everybody see the point there? That point is the 3. And this point right here is the 4, and this point here is the 5. So if I read right here, this would be 3.3, and it's 2 zeros, and I'll tell you that in a little bit. So if this is 0.30, and this is 0.4, watch this. This is 30, 31, 32, 33, 34, 35. Here's another point that's halfway between them. 36, 37, 38, 39, 4. So I mean, I'm looking around the classroom, you know, at 5 people to see if they're getting it or not. I can't see whether you guys are getting it or not online. So let's just look at it again. At the 3, this is the number 3. And then this is 3-1, 3-2, 3-3, 3-4, 3-5, 3-6, 3-7, 3-8, 3-9, 4.
I have a question.
Yeah.
Why is the spacing not uniform? I mean, there's within one black hash mark, there's a 0.1 change, right? But the physical spacing is not
This,
the same.
this, and this is the same. It just doesn't look the same, but it is.
Okay.
It just looks weird because there are, you know, the points and then the not points, but it's the same distance. It
Okay.
just looks off.
It's
But
just visual.
notice,
Okay.
notice it's just below and just above the bars is where the trade-off happens, where it changes, right? So how many decimal places can you read on this rod? Okay, you could read the black number, and you could read whether it's just above or just above, just below or just above each bar. That's 2 decimal places, but our last number is always an estimate, right? So we actually read it to 3 decimal places. Okay, so let's go around the room or with everyone. And let's just start down here. So let's just start at the top. So we're going in alphabetical order by first name. You guys be ready. Okay. So Alan, let's go first. Ellen, you're getting a hard one. What is this? This might be the hardest one on the whole page. So what's the whole number going to be?
It'll be 0.5.
The whole number, remember, that's the red. So it's
Oh.
between 3 and 4. So it's got to be 3
3.
decimal.
right.
And then, yes, you're right, it's a 5, but the next number here, so this is the pink. The next number is the black numbers. When you're between here and here, is there any black number?
No.
No, so it's got to be 0. And then you're right, 5. So it's between 3 and 4, so it's definitely 3. We didn't hit the black number 1 yet, so it's got to be 0. Then it's a half, And then we have to put an estimate. And it
Right.
looks to me like it's dead on to that corner. So it's 3.050. Okay, Amani, you go next. Yep, 3.100 because it's 3, 1, and it's right at that point. Ashton,
3.200.
yep. Beth. Yeah, let's scroll down, sorry.
3.4.
No, take your time. Yep. Yeah, great. Connor. Yep. Great. Daniel,
Ooh, I got the fun one. 3 looks like 7. I got count. I should just count backwards. That would be easier, right? 3.78. Wait,
I always count forwards. I don't
right,
count
5.
backwards,
Yeah,
and
there
I
you go.
always count
5.
from the point.
Yeah, 3.88, I'll say, or sorry, 3.788.
Try again. 3.7.
3.756.
No, you were right. 88.
88. Okay.
Yeah, sorry about that. That was me.
No worries.
Okay. Edgar. Edgar. Okay.
Sorry
Joanna.
about that. Can you hear me or not?
Yeah, I can.
Okay, so I would say 3.899. All right.
Try again. Look at where the points are.
3.9.
Yeah, 3.9.
I will say 9 for
Well, this is
3.9.
where, right here is where the point
Oh,
is,
my bad,
right?
my bad.
This is 9.
Yeah.
So 3.9.
3.94 render.
Don't
4 or
ca-
5.
don't guess. Count. This is 3.90,
Okay.
3.91, 2, 3.
Okay.
All right.
Yeah.
Joanna. I guess this is another hard one.
It's a 4.1, 2. Wait,
Yeah, but it's not, but the
0,
two.
2, 0, 2.
Yay, awesome.
Sorry.
Awesome. All right, so it takes a lot of practice, you guys. All right, it takes a lot of practice to do this. Let's see, there's some others. Let me go back to, I'm gonna share the screen. And I'll go back to the leveling lesson. Let's see. So here's a little description. The red numbers represent the foot. And I'm wondering if it's the same. No, it's different. Good. Okay. Jorge, this one. And notice, you see now you're really seeing it. You see there's a 4 here. And then because you can't see where the 3 is, they put little red 3s. Okay, so it's between the 4 and the 3. So, so Jorge, this one.
You said that one's between the 4 and the 3?
Yeah, so here, up here is the 4, right? And it increases going up the rod. So you got to be in the 3 area. You can't see the big 3, but they put a red one here just so that you know you could still see it.
Oh, okay, I see. Give me a second, okay?
Yeah. Actually, could I put this in here?
So would it be 3.6? I'm not sure the other number.
Okay, so it's, it's 3.6 right here, right?
Yeah.
So 3.61, 3.62, 3.63. And then if you want to put a 0 at the end, you have to have 3 decimal places. So 3.630.
Sounds
do it
good.
again? So this is 3.6. The black number is the 10th place and the bars are the 100th place. So this is 3.60, 3.61, 3.62, 3.63.
Sounds good. Thank you.
Okay, yeah. Jose, how about this one?
Can you hear me?
Yeah, yeah.
So it's 3.78.
So let's see, 3.75, 6, 7, 8. Yep. And then put a 0 at the end, right? Because it's got to be 3 decimal places.
3 decimal places. Got
Right.
it.
3 decimal places. Laura. Say it louder. Yep. 3.991, 92, 935. 3.935. Okay. All right, let me stop sharing. Okay, how are you doing? Look in your textbook. There'll be rods there to read. Okay, so just play with it. It takes time, right? It takes time getting used to. Make sure that you're looking at it and comfortable before you go out to the field. Okay. There's another page in the packet that I want to show you, but we're not doing it. So let me just pull it out. Let's go up to week 0. Oops. Lecture packet. Open. There it is. And I'm going to go down up 16. So what we see in the lecture packet is here's the definitions we saw, and this was an example of leveling notes. And then here are the things the rod readings we're doing. And these are more complicated rod readings and we're not doing them. Did everybody hear that? Are we doing them? Are we doing them? Are we doing them?
No.
Okay, great. Thank you. Okay, I'm going to stop sharing. Okay. So, we have one more thing to do. Let's take a 10-minute break. And let me actually have you look at something. What I'd like you to do is, does everybody see the sheet that I have up here now? It looks like it's allowable errors. And I want you to just take a look at that, but let's be back at 20 after. So let me go into, let's go into Zoom, back to Zoom. Stop sharing for a minute and the chat. So let's take a short break and I'm going to show those of you who are here the equipment return at 2:20, yeah, like it's 2:20 in the afternoon, 9:20 p.m. Okay, so I'll see you in a little bit. So if I share my screen, the last part of today's lesson was to look at what is the allowable. And actually, let me edit that, say what the allowable accuracy and precision error. Okay, and it's on page 19. And so what I did is I printed it out because I like just to write on stuff. So, and I'm going to pin myself here. Oh, it's already pinned. Okay, so let's take a look at this. So it says that with horizontal control and vertical control, survey the accuracy standards. So we already know that the error is 1 part per X, right? So let's take a look at this. If it's an first order survey, you're allowed a 1 foot error in 100,000. If it's a third order class 2 survey, you're allowed a 1 foot error in 5,000. So which one is stricter? The top one. Stricter is this way. Right? Stricter meaning they allow less error. Allowed. All right, so let's take a look at, let me give you some, what these, I just went to lick my finger to turn the page and I can't lick my finger. Hang on a second. Let me tell you what they are. So a first order is for military and defense, dams, and tunnels. So that's what first order is. Second order is large construction projects, and interstate highways. That's second order. Third order is small engineering projects, small topos, and boundary control. That's survey, that's property surveys, right? Okay, so these are the types of surveying projects you might be working on that would require whether they're first order, second order, or third order. The vertical control below is all based on, based on metric, but I just wanted you to see that really the greatest error you really could have is 1 in 5,000. Okay, that's really the largest error you're allowed. Well, let me remember Kyle said he changed your project, so when you're doing your surveying, you actually are allowed more error. Okay, so I'm going to stop the video here. And let's go back to sharing my screen. And I'm going down to the differential leveling per lab. And let's open it up. And let's take a look at the amount of error he's allowing. So it says the final elevation of the benchmark obtained by completing the circuit should agree with the initial elevation within 0.010 radical n, where n is the number of setups within the loop. So in a case where we have, let's say 3, if we have 3 setups, what is the error we're allowing? 0.010 radical 3, right? What's that turn out to be? And this is in feet. Point 0.017 feet. So that's the allowable error you have. Now, depending on, let's see how much, I don't know what your lengths are going to be. But see, this calculation here is going to show you how to actually divvy out the error that you get at the end. But so let's see, if you could get an error of 0.17, and let's say we're saying 1 part in 5,000, how much would you be surveying in order to, oh, I'm writing on my hand, I'm writing on the paper again. Let me go back. So if on our lab, we're allowed a 0.17 foot error because there are 3 setups, and let's say we're allowed a 1 foot error in 5,000, what is this value right here? $86. Try it, just 0.017 divided by 86, is that about right? Somebody get it? 0.017 divided by 86.7, yeah? Okay, so that means that this is so you're gonna be, if you're surveying 87 feet, you're allowed this much error to be within the 1 over 5,000. Okay. Right, that was the last topic. So let me stop recording.